question is, a cuboid has dimensions 12.5 centimeters, 15.3 centimeters, and 24.2 centimeters. These dimensions are all given to one decimal place. Calculate the upper and lower bounds for the volume of the cuboid in centimeters cubed and millimeters cubed. Keep your answer in standard form. A cuboid is a rectangular prism, so think of a box, tissue box, perhaps, with the dimensions being the lengths of each of those sides. The volume of a cuboid is the length times width times height, and we need to work out what's the boundaries, what are the possible values, if you will, for the volume. Given that each of those measurements is not exact, there's a small range of values that they could be. We're told that they're correct to one decimal place, which means that they've been rounded to the first decimal place. And any number from, let's look at the first one, 12.5, any number from 12.45 to less than 12.55 would have been rounded to 12.5. So they would be the upper and lower bounds. So let's write that down. 12.5 is going to have a lower bound, which is it is greater than or equal to, and it has an upper bound, which 12.5 is less than. The lower bound is 12.45. Anything above that or equal to that will be rounded to 12.5 when you round to one decimal place, and anything below 12.55 will be rounded to 12.5. And so that's the boundaries of the range that any number in there gets rounded to 12.5. And so there's a lot of numbers in that range. The second one, 15.3, we do the same thing. What is it greater than or equal to? What is it less than? It's greater than or equal to 15.25. It's less than 15.35. And for the final dimension, 24.2, we do the same thing again. 24.2, what's it greater than or equal to? What's it less than? It's greater than or equal to 24.15, and it's less than, it has to be less than 24.25. Right, so now we're trying to find the volume. And for the boundaries of the volume, we want to know, well, what's the volume going to be greater than or equal to? And what's the volume going to be less than? And to do that, we look at the formula and it says length times width times height. And we go, well, what is the smallest possible answer that we could get given these ranges that we have for each of the dimensions? And well, of course, you're multiplying. The smallest possible answer is going to be multiplying the smallest numbers together. So we look at all of the lower bounds and we multiply them together. So grab your calculator and we punch in 12.45 times 15.25 times 24.15, and we get an answer. It's a lot of decimal places. We'll just write it to 3 at the moment, 4,585.175. And for the largest number that it could be, that the volume could be, we look at the largest that each of the dimensions could be, and we punch that into a calculator as well, and we get 12.55 times 15.35 times 24.25, and that gives us an answer. So the volume has to be less than 4,671.581. The question asked us for the answer in standard form, also known as scientific notation. We will take, well, let's take the first 4 digits. So scientific notation, converting that 4.585 by 10 to the power of 3 cubic centimeters, and the volume is going to be less than 4.672 times 10 to the minus 10 to the 3. It's not minus 3 centimeters cubed. Right. Now we also have to give the answer in millimeters cubed, and millimeters cubed we have to convert, and rather than convert each of the individual measurements to millimeters and then working it out, we can convert the answer, and we have the ability to convert cubic centimeters to cubic millimeters. And the best way I find to remember how to do it is just forget the cubes for the moment and then just ask ourselves, how do you convert centimeters to millimeters? And to do that, of course, you multiply by 10. And then if we're going to convert cubic centimeters to cubic millimeters, we cube the conversion as well. So whatever you do to those units on either side, we're going to do to the conversion number. And so we're going to multiply by 10 cubed, which is 1,000. So each of those standard form numbers, which are cubic centimeters, we multiply them by 1,000 and we're going to get standard form cubic millimeters. And when you multiply by 1,000, the power on the 10 is just going to go up by 3. And so you get 4.585 by 10 to the 6 millimeters cubed. And that's the lower boundary for the volume, and the higher boundary for the volume is 4.672 by 10 to the 6 millimeters cubed. And you're done.